Hello, everybody. So I'm going to talk about big data and the future of DevOps and talk a little bit about what we're doing at Affiniate under the brand 10IO. So why operations? Like, what's the problem we're trying to solve? Well, in 2008, the average revenue cost of unplanned outages was estimated to cost about $2.8 million per hour. Obviously, that depends on industry. It's a lot of money that's being lost by different organizations, different enterprises. 59% of Fortune 500 companies experience a minimum of 1.6 hours of outage per week. The best of class of these companies are losing about $75,000 a year from revenues lost, and the ones that are really bad at this are losing on average $2.8 million, almost $2.9 million a year. Depending on the type of business application that they're running and that experience an outage, you can see that you can lose anywhere from $11,000 a minute down to $700 a minute. And actually, there's the upper bound on this is actually much higher than that. If you are entirely dependent upon an operation of your infrastructure for revenues, then every minute that you're down is potential revenue lost. Potential opportunity lost, and the recovery time, the cost that it takes to recover from outages is extremely high. What are the types of unplanned outages? Well, there's obviously like the acts of nature, the acts of man, things that can be done maliciously or unintentionally. Threshold breaches or system overloads, things that weren't really planned for or not noticed. Things like data connection saturations or web server capacity being breached. There's actual physical or hardware failures that can occur with solid-state devices, storage devices, actual power supplies can take down. A lot of outages come from power supplies actually failing. And there's software and logical failures. And then there's also, we'll see that actually configuration causes a lot of these unplanned outages. There's estimated 80% of unplanned outages are due to ill-conceived or ill-planned changes in the environment. Now, this could be from a deployment of a new software application or an upgrade of an application that causes an outage and unintended consequences. Or it could be somebody logging onto a system to tweak a configuration file, thinking they're doing something good. You know, they remote shell in, and everything may seem like it's running for a while. That change goes undocumented, and the server crashes. And this kind of talks to that as well, that about 50% of those outages are going to be 50% of the outages are caused by change configuration or release management issues, which is why, so the goal of ops, or the goal is to provide the right size capacity for your operations and minimize or prevent downtime. You want to be fast, you want to not make any mistakes, and you want to stay out of trouble. And so how would you do this? You want to institute changes quickly and appropriately. You want to maintain consistency of software and hardware as much as you can. And you want to manage changes from one place if you can. Try never to log on to an individual server, and you want to monitor your infrastructure operation. And every aspect of the infrastructure operation that you can. Now, a lot of this is the reason why cloud computing has coming to the forefront. With cloud computing, you're able to maintain consistency, at least of the hardware. So even if you have inconsistent software, you're abstracting at least one layer away that you have to manage, and you're just deploying upon an infrastructure that somebody else is operating for you. It doesn't take away all your problems. You still have to try to maintain consistency on your software. But you also now, since you have abstracted away the underlying computing infrastructure, certain things are shielded from you. You may not know whether, you may be trying to debug a problem that's actually underlying in the infrastructure. I was talking to a gentleman last night at dinner, and he said that they had spent a couple hours tracking down a problem that they're sure is at the switch in the cloud service provider and not in their application, and there was a lot of finger pointing back and forth going on about how to resolve the problem, and ultimately it did turn out to be the switch. But because they weren't instrumented to get visibility into the hardware that their application was running on, because they were supposed to not have to worry about that, they weren't able to fully debug the problem. So why is it so hard to maintain the consistency and keep these infrastructures operating? Well, there are two entities involved in this equation. One is the developers. So it's the developer's job to maintain the software, align the software according to the business requirements. And that, by necessity, means there's going to be change. And they do this in order to keep the business in business. On the other side of the equation is the ops. Now, ops wants to keep the infrastructure running. They want to minimize the amount of change, because every change incurs risk. And they also want to keep the business in business. So what DevOps seeks to do is to bring the two parties together so that the enterprise software stays aligned, that the infrastructure stays running, the business stays in business, and that we're able to mitigate the risk involved in doing all of these things. I'm not going to go into the detail about what DevOps is. There's a whole other track for that, and you guys have been reading up on that, I'm sure. But at its core, what DevOps is seeking to do is turn infrastructure into code, or treat infrastructure as code. And in order to do this, there's a couple steps. One is to actually take the monolithic, complicated infrastructure that needs to get deployed and decompose it into composable components. We want to also define a way to configuration manage these components so that we could actually define the processes to build these components, and then automate that so that we have a repeatable way of creating infrastructure, so we have that consistency in the software. Compose these automations in a way that allows us to configure and deploy the actual infrastructure, and then configuration manage all the compositions and automations themselves, which is in itself code, in addition to the application that's gotten developed. So some of the DevOps tools that are used, there's the operation system installation tool. Pixie is an example of one of them. Configuration management, there's a variety of tools for that. CF Engine, Puppet, and Chef. For composition, a lot of people use Vagrant, and there's some other tools as well. And there's a whole slew of monitoring tools, including one of the sponsors of the conference, Boundary, has a new solution out. But is this sufficient to do all the things that we need to do in order to keep operations operable? I would maintain that actually it's not the case, that DevOps actually doesn't solve the full problem, because it doesn't really address hardware. It's really addressing the application layer and things that touch the application layer, but doesn't talk about all of these things, or maybe only touches upon some of these things. On the left side here are many of the things that DevOps addresses, things like caching, some of the algorithms that are used in order to maybe define how you do the caching, the composition of how you actually create the application, and even all the way up into hardware spec. But doesn't really touch, in most instances, what's going on over here. In the promise of cloud computing is that you don't have to really do any of this. Somebody else is doing this. But that's really just that's just pushing the problem onto somebody else. Even down to something like, which is, you don't hear much talk about in the DevOps conferences, of NOC management. How do you maintain physical security? How do you, where are you going to locate the NOC? And even things like power supply, which causes a lot of the outages for applications. So ops is more than just the apps. It's just a conceptual hybrid data center I pulled off the internet, just to show that when you're laying out an operation data center, there's actually nowhere on here do they really talk about the app. This is all the stuff that the app has to have in place in order to run. This is everything that's assumed. So infrastructures are actually more complex than what DevOps seeks to solve. And because they're that complex, it's difficult to predict when they're going to fail, identify why they have failed, and determine what has actually failed. And this actually increases the cost of an outage by lengthening the time it takes to identify that an outage has occurred or a breach has occurred, and then the response time required in order to address the issue, either circumvent it or actually fix it. So for infrastructure to really be code, all of this, not just this, has to be decomposable, definable, has to have automations that can be reliably repeated, has to be composable and configurable, configuration manageable. At least the pieces that you don't actually have to plug in. So things like putting a new algorithm on your load balancer in order to address a change in the way that the users are interacting with the system. That, again, is not really covered in the DevOps scenario, at least not in best practices as they're discussed right now. And yet that's critical to whether the application is going to stay up and be responsive. So some of the other tools that ops people use have to do actually with network configuration, device configuration, the management of those device configurations, and the monitoring. There's a whole other set of monitoring tools that usually comes into play depending on the type of network devices that you have deployed on your system, deployed on your infrastructure. Some of the tools that were displayed earlier, like Nagios, I think Boundary as well, Xenos, and Splunk, and CollectD as a daemon actually allow you to collect data not just at the application layer but down into the hardware layers as well. But they also have to be used in concert with processes and tools that are not being discussed in DevOps. So I want to switch gears a little bit and talk to you about how we think about infrastructure. We actually think of infrastructure as managed states. So at 10IO, at Affiniate, we think of infrastructure as states that need to be managed. If you know how your infrastructure needs to operate, you can define that as a state. So if you can define all of this as code, or at least as parameters, then you can define the state that you desire your infrastructure to operate in. So by taking all of this as your state, and adding your performance characteristics, you can define transitions between desired states. So what does this look like? As a simple example of what it takes to deploy a simple web app, let's start with a state 0, which is basically the bare infrastructure. And by running our infrastructure's code, we can transition into a known state, a desired state, where we have a web server, a load balancer, and 2 database servers. So now, assuming that we're in that state 1, where everything's running well, if a DevOps operator is using his monitoring tool, using Nagios, using Boundary, and sees that there is an issue with the database performance, they may choose at that point to address that issue by transitioning to another state, meaning they run the code that's required in order to get from state 1 to state 2. And in state 2, they may determine this operator may determine that it looks like the load balancer is having an issue. So let me bring another load balancer up online and insert that in between the web server and the database servers. So he brings a second load balancer on, monitors, make sure that load balancer is working well, and then transitions to the third state where that first load balancer that was causing the issue is taken offline. So instead of getting into a state where there's an actual failure, they just ran the code to transition from state 1 to state 2 into state 3, and now this infrastructure is running in state 3. I'd say that didn't solve the problem, that they're still seeing database performance issues. So it may not have been that load balancer. It may have been that load balancer in concert with something else that's happening on one of the database servers. Or it may just be that the database servers are saturated for some reason. So in this case, they'll transition from state 3 by bringing into state 4 by running the code required to bring a third database server online. Now this code is very likely going to be the exact same code that's required that was run to bring database server 1 and 2 online. It's a repeatable process the infrastructure operator uses to bring database server 3 online. And now, and this is running. At this point, the infrastructure operator may realize that actually the problem was with database server 2, and that with 1 and 2 and 3 are able to handle all the load, and all the performance issues goes away. Runs another set of code to take database server 1 down, and now we're in a new state, a desired state, where we have web server, load balancer, and 2 database servers running. It happens to be a brand new load balancer and a brand new database server from the original state. What does an outage look like when you're thinking about infrastructure as state? Well, basically, in this case, this outage demonstrates what happens when is illustrating what happens when web server 1 goes away. Something happened, nobody noticed that the web server was about to fail, or maybe it just failed catastrophically, and you're in a failed state. The application is not running. And so there was a transition here, an unintended transition, into a fail state. So what would normally happen in this scenario is that if you're running monitoring software and alerting software and you're gathering data off your infrastructure, hopefully, actually, before this happens, you'd be getting alerts. Dashboards would be turning red on your monitoring software, and somebody could take proactive action to keep this from happening. But that doesn't happen all the time. Sometimes things fail catastrophically without any warning, and you get into this failed state. And this is the typical case where now infrastructure operator is now scrambling. All the pagers are going off, BlackBerries are going off, and teams are being assembled in order to try to figure out what happened. Well, first, just to recover, bring a web server up online, and then figure out why did this original web server fail. In this case, again, if they have infrastructure as code, they could just run the transition software. It takes them out of this failed state to bring a web server back online. They can get back to this state number 5. If they don't have infrastructure as code, they're running through a bunch of manual processes, running scripts, trying to figure out what to do in order to bring the web server back up online. So this is what a DevOps process flow looks like. It's, find my pointer here. It's infrastructure creating, sending selected infrastructure, what we call telemetry, through a bunch of tools that provide visualizations, alerts, and analytics that fire off triggers to dev operators who are also getting external triggers and deciding to take actions to change that infrastructure, to manage that infrastructure. Well, if we remember, so DevOps tools still require humans to be involved. And if we remember this statistic, humans are the major cause of the errors. So while DevOps does a lot to automate the process of running infrastructure, at least the application part of the infrastructure, it doesn't solve the problem completely. So how do you mitigate this? You get Autonomic. In the early 2000s, IBM had a research initiative called Autonomic Computing, in which they were trying to develop servers that would self-heal, basically. With the advent of the cloud, a lot of that initiative went away, and they folded a lot of their tools, what they developed, into Tivoli. And so it kind of lives on, but you have to have IBM's suite of tools, and it is obviously very expensive. But with an autonomic computing infrastructure, what we're seeking to develop is the ability to run diagnostics, is to turn any computing infrastructure into one that runs diagnostics and checks all the time and takes actions on its own to repair and address any anomalies that it finds. So how would that work? So all of this can still stay in place because you still want to have human operators involved. You just want to minimize their interaction with this infrastructure. And what we add here is what we're calling Autonomic I/O, but it's a rules engine that gets all of the infrastructure telemetry from hardware, from the bare hardware all the way through the application stack, from the network elements, routers, switches, all the devices that are on the infrastructure, including potentially smart sensor grids and even sensors that are in the NOC, things like power regulators, power supplies, cooling sensors off the cooling systems. The engine itself does the decision making, looks for patterns and anomalies in that data, and then takes the appropriate action in order to manage the infrastructure. So what it does is it ingests all the telemetry, it identifies anomalous patterns, and it triggers transitions between desired states. And the idea being you minimize the amount of time you spent in a failed state. Even if it gets into the failed state, there's still a chance that the rules engine can figure out how to get out of that failed state. So if a web server fails and it's no longer getting data off that web server, somebody pulls a plug off that web server, it would automatically know that a web server is supposed to be sending data. It's missing. Let's reconfigure let's reconfigure another web server to take its place and route traffic to that server. Oops. So we have no more failed states, or at least that's the goal. So instead of that last state here, where we had a web server just disappearing and requiring manual transition back, we would, in this case, ideally, Autonomic I/O would see that this web server is about to die, or has died. Well, let's say it's about to die. Bring another web server up online really quickly by going through all of that code that is required to deploy and configure that web server, and then take down the bad web server, and then fire off alert to human operator, let them know you need to pull that server out of the rack and replace it. So this is a infrastructure maturity model that we're playing with. It's still a work in progress, but the idea is that there are a lot of organizations that are still at a very basic level of managing their infrastructure. Probably nobody in this room, but where they're managing the elements of that infrastructure at an individual level. The next step up would be monitoring that infrastructure and the elements on that infrastructure, and using tools like Nagios, like Boundary, like Splunk, in order to at least get an idea of when things fail and what they need to do in order to recover from that. A step up from that is what we call reactive, in which we think actually DevOps is, where when a failure occurs, there are things that are defined and known that need to occur in order to recover from those failures. And the next step above that is proactive. That's where we are getting to with Autonomic I/O, and where the infrastructure itself can use all the work, all the definitions that have occurred in a DevOps organization, plus patterns that are specified by the dev operators in order to recover proactively. Predictive would be the next step where we're trying to get to, which is for patterns that haven't been specified, where you can't specify every type of failure that's going to occur. So there are things that are, more interesting ways. There are more interesting ways to fail than can be defined. In those instances, we're hoping that we can build an engine that would know how to respond to those failures, and at least start to take some corrective actions, in addition to letting a human operator know what has occurred and what actions have occurred, so human intelligence can then be applied to try to solve the problem if the engine itself can't. And the ultimate goal is to have infrastructures that are fully autonomic, where the operator's main interaction with the infrastructure is by setting policies, objectives, and performance metrics. And the infrastructure then is able to manage itself in order to meet those performance objectives. So the future is one where the best practices from DevOps combined with big data, infrastructure telemetry, and a rules engine, a smart rules engine, can create autonomic computing infrastructures that can, for the most part, run themselves. And that's my talk. Thanks. Yes.
So, state management, as far as how it detects that things are different or changed or need to be repaired, how much of that is actually managed by software now versus what still needs to be done?
How much of it is?
It's like all automated now, as far as like bringing up web servers and, I mean, like is that fairly common as far as what you've seen? Do a lot of people actually do full touchless like automation for down systems?
No. What we've seen is that, so automation is a term that's used a lot, which is why we don't use it for our system. The level of automation that we see right now is one where things like configurations are managed in Puppet and Chef or CF Engine, and those configurations can be run, but it's a human operator who's determining what needs to be run and when. Even when those recipes, if you will, are composed and run automatically using something like Vagrant, it's still human that's making the decision to run which composition to run. And there still needs to be a human involved to determine whether things are happening the way they're supposed to happen. So just because you ran a Puppet script or a Chef recipe doesn't mean that everything happened that was supposed to happen. So there's still, while there's a lot of automation in pieces, there isn't the ability now to just say, bring up a web server and have it be fully deployed and trust that it's going to that's a repeatable process that's going to run. Now, some configurations are probably simple. I mean, there may be some organizations, obviously what I just said is a blanket statement. There are probably some organizations that are able to run, where they have these fully tested recipes and they're able to run them. They haven't made a lot of changes. There doesn't need to be a lot of testing involved or a lot of decision making, and they're able to do it touchlessly, if that's even a word. But for the most part, that's not something that I think even the organizations that are running things like Puppet Chef or CF Engine, the ones that are DevOps practitioners are trusting that that's going to happen without them actually monitoring what's going on. One of the, I'm sorry, I should let somebody. Is there another question, or should I keep expounding on that? Go ahead.
How far are you in implementation of this? Is it just an idea, or are you?
No, we're a little less than a year into the implementation. We started building the core of Autonomic I/O in August of last year, and actually for a different purpose. And January of this year, we decided to tackle this vertical, and so we've actually re-engineered some of the key pieces in order to be able to address the scalability issues involved with trying to deal with a massive amount of data that comes off of infrastructures. So we're well into the process, but it's still very early in the development. Any other questions? Okay, thank you.